Okay, welcome back, guys. We'll be talking about radicals and roots today. Earlier in this earlier lecture, we talked about the review of power and exponents, and we laid out some rules there, or some we took care of some restriction that we had. And today's session we'll be talking about radicals and roots. What is a radical? It is the opposite of an exponent, and the symbol is given as this, like that, or just say that is, oh my god, my writing is not okay. So that is the symbol of the radical expression, and this is also called a root. And so that's, yeah, opposite of an exponent. So if you have anything in here, something in the index area, so this will be a radicand, this will be your index, and this is your radical expression. And I'm glad I have it here. So this will be your radical expression. This is your index. This is your radicand. Radicand. Okay, so that's the complete expression here. So we have index, we have radical expression, we have a radicand. This number can be written down as that, is this value. So it'll be a to the power b over c. So that's the power of a, and that's divided by c. And that's why we call it its opposite of exponent, because being exponent, for example, a to the power b means a is multiplied by itself b many times. So they say like b many times. But here is a is multiplied by itself b divided c many times. So some value of the b, the exponent b is already taken because it's divided by c. So that's how we call it. It is the opposite of an exponent. Okay, I'll clear this so I shouldn't confuse you, and it will make sense when we keep going ahead. Okay, so a complete radical expression would be, for example, 49 under the radical expression, and we say radical expression of 49 with root degree of being 2. The index is our degree, or degree of root. So that will be your complete radical expression. We don't write with the square root 2 or degree 2 because the default setting for the degree 2 is 2, and we do not write it because that whole radical expression here, that whole line, it seems that there is no number. If there is no index, the index is always 2. Okay, so to understand these things, we will talk about some example, and let's cover some example here. Write down these following numbers using radicals. Radical expression, actually I'll just, yeah, radical expressions. So a is 3 to the power 2, which is 9. So 3 to the power 2, which is 9. How can we write down this number as a radical? So we will say, alright, so this will be a little bit tricky because I haven't given you anything hint, but we can write down. We can do 3 to the power 4 divided by 2. That will be same as that one, because this will be 3 to the power 2. This will become like that. But that being said, we can write down as a radical expression right now. The index is 2. The power of 3 is 4. So how we simplify that? We will not simplify because it's been asked to do just a radical expression. Because 3 to the power 4 divided by 2, we can write down this as that, and that will become same as 9, but is a radical orientation of that number. Okay, I'll leave it right here. So b is 15 to the power 1/3 or 1/3. So we know 15, the index is 3 here, the power of 15 or radicand is 1. We don't write it. So that's all for that. And c is, because if we can simplify it, we will simplify it, but we cannot simplify it. C is 81 to the power half, 1 over 2. So we can write down this one. The index here is 81, index is 2. We don't write it. So that will be the radical expression, but we can simplify that one as we will simplify that too. So we can simplify that. Let's do this. Will be 9 square, and the index is already square. The square will cancel out that. The square of the radicand, the power of the radicand will cancel out the power of the degree of the root or index of the root. So this will become 9. Okay. Now number D is 125 to the power of 2/3. D is 125 to the power of 2/3. So let's see, we can write down as a radical expression. So we know the index is 3, 125, and that is the power to the 2. Let me simplify that a little bit. Okay, I'll write it down smaller so I can put the degree of the 125. Okay, so that's the expression. If it can be simplified, we will go simplified, but I'm not too worried about that. So let's go to the E. E is 4 to the power of 8 over 9. So we got a bigger degree root there. So we know the index here is 9, because this number, the bottom number in the power or the exponent, is the degree of the root or the index of the root, the index of the radical, and the top is the power of the radicand. So that's, here we are, and I will leave you guys with one. I'll solve f is 9 to the power 1/3. We know the degree of the radical is 3, or the index of the radical is 3. So it'll be 3 cube root of 9, because the power of 9 is 1. Here we do not write it down. So what is G? G is 301. 301 to the power of 2 over 5. You guys solve that. You guys try that. Okay. Cool. We did talk about quite a few examples here. So this example will prepare you for the next lecture. Will be square roots, and after that we'll be discussing cube roots too. So I'll see you guys next time.